Hello class. Today we're going to take a look at a little bit more about JavaScript data types, meaning we're going to look at objects, we're going to look at maps, we're going to look at some specific types of objects, meaning the date, the strings, and the math types, and then we're going to take a look at some exception handling. So we're going to start with that today, and we're going to do some examples, a little different than the book. This way you have another point of reference. So I've gone ahead and I've launched the editor and I've reset it to our default. And we're going to take a look at some examples here. So we'll run it real quick. See, we have our output. So let's start out by looking at what an object is. Well, an object is an unordered collection of properties. Meaning that we can put in a grouping of different things that we want to keep track of. Maybe a name, maybe an age, maybe an ID number, maybe a GPA, if we're talking about a school object or a student object, and some other stuff. Maybe if we're doing bank accounts, we could be thinking about a bank balance or a bank type or something along those lines. So I think the best way to do it is look at an example, and we're going to go with we'll go with the student type, I think. I'm going to get rid of all this fluff here because we really don't need it. And we'll start building out our object. We're going to create a student object, and we'll call it student. And the way you define an object is by, well, first giving it a name, and then you're going to build the collection of properties inside the object, inside the curly braces. Now, what is a property? So a property, very simply, is a name-value pair, meaning that the name is the identifier. You can think of it as a variable, and the value is the value of that variable. So we're going to take a look at a couple types here so we can get a handle on it. And every student has a name, so we're going to create a name property, and we're going to give it a value. We'll give it a value of somebody's name. So here is our name. Maybe it's not a best choice because it looks like it's a reserved word. So we'll give it full name equals, and we'll call it, we'll give it a full name. So now we have our full name. We will give it a major. Let's give the student a major. And my major back in the day was computer science. And my GPA at the time was, oh, I don't know, I can't remember that far back. But we'll call it, I think it was 3.875, I believe. We're going to go with that because at least it's a nice round number we can tinker with. And then we'll list some courses that I took, and we'll give that a value. We'll give it an array. We'll give it a couple of courses, and we'll give it good old CST 161. And I took a Java class. Well, not really. Java didn't exist then, but we'll pretend. And we'll give it a database class too. Oracle didn't exist then either. I don't think so. But anyway, we'll give it some courses. So now I have my list of courses. I have my GPA, I have my major, and my name. And let's just do a quick run, make sure it all works. And oh, I got an error. What did it not like? It did not like my name. Now, why did it not like my name? Because I used an equal sign. We don't want to use equal signs. We want to use the colon to make the key value pairs, or the name value pairs. So if I run it again, the program will produce no output, which is expected because there's nothing to print. So this is the object. The student is the object. So we're going to do some looking at some of the values of the variables or the properties, and we're going to see how we can do it. Well, we'll start with a console.log, and I can print out student.name, full name. And if I run this, sure enough, it prints out my name. If I do a console.log of student.major, so you could see we're using a dot notation where we give it the object's name and the name of the variable that we want it to display. And we can access those directly. There's my computer science. And we'll do one more. And we can try courses. Now courses is an array. And you'll see it prints out the entire array separated by commas. So there we have our ability to create the object, give it name value pairs, and give it different values. So that's all well and good. Objects should also have methods. So methods are ways of accessing objects, and we're going to build a function. So we're going to build a function inside of the student object. So we're going to build a custom function, and let's call it, I want to print my name and my majors. Let's call it introduce. And that's a function. And it doesn't like introduce. Did I spell it wrong? I probably did. introduce. Okay. Introduce function, and we will return, just do a simple return of hi, my name is, and we're going to give it the name. So we're going to do the bracket this dot full name, so we can access the variable inside the object. So we use the this modifier, and then I'll print out my major, and again we'll do a $, curly bracket this dot major. And we'll put the word major in there too to complete the sentence. And we'll close out the bracket, the apostrophes, and we will give it a quick run. I'm very concerned about this red. I don't know why it's highlighting in red. Hopefully it won't give me well, it did. It gave me an error. Unexpected identifier. Okay, I think I need a comma here for the object. I think, there we go. I forgot the comma. Good. So we should be able to try it now. I still have my original print statements, and that's working great. But now we can use the function, the introduce function, or introduce method, and it will give us hopefully a little more output. So let's temporarily comment out these lines, because we know they work, and we don't need to see that output every time. But now I want to do console.log introduce. I don't need any parameters, so I'm just going to call it directly. Let's see what kind of output we get. And again, we got an error. That's because I forgot to do student.introduce. So whenever we're calling a function, we need to give it the object we're referencing. So we have the object dot the method. And now if I go ahead and run this, it is printing everything as it is. It was not expecting to do that. So let me take a look at that and see if I could fix that up. Okay, so we're going to go ahead and we're going to fix this and put in the proper tick marks instead of the apostrophe. And now you can see how the highlighting has the coloring of the variables and such as change, so it's no longer just a string. It now gets replaced by these variables. And now if I run it, great, it filled out all the fields with the values that I wanted from the object. Okay, so we could see the benefit of an object and how we could store multiple key value pairs together, and it works okay. There's a better construct I would prefer to use, and I use more in my coding that I do now, is maps. Instead of an object, I tend to use maps. So let's take a look at a map object instead of, well, a standard object. So a map is more like a JavaScript implementation. And we can define a map by giving it a list of keys and values, but instead of using the naming conventions and the very specific data types, we can pretty much use any data types we want and any type of naming that we want. So let me demonstrate what a map would look like for a student, similar to what we did for objects. So we're going to create a new map, and we'll call it student map equals new map. So now we've got more of that JavaScript syntax going, and in it we're going to define what we want in the map. And we're going to use the square brackets so we can list out the multiple items, because we're going to build an array of items. And we're going to start out with the full name. So this time we'll give it a bracketed, comma-separated list of names and values. So we'll do full name and actual name this time. And we can keep listing down as many different keys and values as we like. So we're going to do just a few of them here. We'll do major. So that's the key. And now the value is computer science. And we'll give it one more. We'll give it GPA. And we'll give it 3.75 again. So you could see that we have our definition of a student map. We have our keys on the left and our values on the right, all wrapped in square brackets. So what I like more about maps is we now have predefined methods that allow us to get and set and check for values. So just for example, I want to, well, first I want to comment out this console log here, because we don't need that. But I do want to put in a console.log student.map, not .map, sorry, student map .get, and now I can get the full name. So it's a very simple standard structure that allows us to get and set data out of maps. So I will run this, and there it is. I got my full name. Very simple thing. You have your get method. You put in the key. It returns a value. So you're asking for a key. You get a value. You can check to see if there is a value or is a key. Maybe we don't know if there's a key. So we can check student.map. Student map dot has. Let's see. Now we can check for anything. We can check for GPA, and we'll see what that prints when we run it, and that's true. And what if we want to check for something that doesn't exist? Well, we could put that in as well. So I'll just copy and paste this line of code. And instead of GPA, we'll put in student ID. There's no student ID number in here, so it should print false. And there it is. There's our false. So we have gets, we have has, so we can check. We can check for the size of a map using a size property. So we could take a look at that now. Okay, so we can check for the student map dot size. And this is a property. It's not a method. So properties do not need the parentheses like a method does. So we can still need a semicolon, but when we run, it'll give us the size of the map, which has 3 key values. If we get it confused and we accidentally put in student map.length, because that would be a logical choice for the name of it, we get undefined. So this is telling us this property does not exist, so we're not going to use it. We'll just comment it out and say does not exist. So we have a length, we have a size, do not have a length. We can add items. We can do that very simply also. Console.log. Well, I'm not going to do console log yet. I'm going to do student map.set. Now, what would you think we need? Well, we know we need a key and a value. So let us put in a key and a value. And we can pick anything we want. Why don't we put in student ID now? Let's try that. Student ID. And I'll put in my student ID. And in this case, I will put in 1, 2, 3, 4, 5. That is not really my student ID, but it's good enough for now. And now, if I copy this line of code back to the end here and I run it, instead of a has, I'll use get and run it now. And now I have my ID. So I'm able to add things to a map fairly easily. Well, I'm also able to delete things from a map fairly easily. Well, let's try student map dot delete, and we just need the key, student ID. And if I run it, it doesn't display anything. But now, if I go to print or use my has again to see if I have the student ID, I would expect false. And there it is. So you could see it's, I think, a little bit easier to deal with a map than an object. But you may, depending on the implementation of what you're trying to solve and what problem you have, an object may work better for you. So you have another tool in your toolbox that you can use to try to solve these issues. So another neat feature we can use now is a loop to look at all the values of a map. So the syntax looks something like this. We're going to use a for loop, and we're going to give it a key and a value, and those are variables now. Those are not placeholders. Those are going to be the actual variables we're going to use to print out and select our values of student map. So for every key value of the student map, we're going to look at each key value pair. And we're just going to do a simple print statement, similar to how we did the introduce function above. So we can do console.log, and we put in our little tick symbol, and we do a $ key, colon, and we can do a $ curly bracket value, curly bracket, and the tick symbol, and then a semicolon. So now this should print out all the key values in our loop, pending any syntax errors, and there it is. So we were able to display our map. You might also think that we could do something like this. Console.log student map. And let's see what that does. And it does. It prints out the entire map. And it gives it in a slightly different format. It's kind of neat that it tells you how many elements there are. It gives you the size. It gives you the key and its associated value in this different kind of format. It shows you what strings are. It shows you what numbers are. So you can print out, you can either use a loop to display the whole thing, or you can use just this simple statement to display it. Choice is yours. Okay, I'm going to save this little bit of code here so I can put it up into the examples later on. So I'm going to save that. And I'm now going to clear this out so I can start looking at the next sections, which will be the string object, the date object, and the math object. So while that's resetting, and there it goes. And there's our default text, which I'm going to delete because we don't really need that. So next thing I want to take a look at are string objects. So a string object is exactly what it is. A string is a string of text. And we have a whole bunch of operations we can do on strings. And I guess that's the highlight of this section, that we can do string manipulation. We can look at specific characters of a string. We can look at lengths of a string. We could replace pieces of a string. We can get substrings, so we can get parts of a string. And all those are done by different methods that are pre-built into the string object. So we're going to take a look at some of these. So we're going to create a string first of all. Test string equals, and my favorite string of all is the quick brown fox jumped over the lazy sleeping dog. Something I learned in typing class a long time ago. Uses every letter of the keyboard in a single sentence. So, I guess the best way to demonstrate this is to just try out the different string object functions and see what they give us. So the first thing we'll look at is, well, we could start with index of or character at. Those are pretty standard ones. So index of we'll start with is the one that returns the first occurrence of a string inside another string. So we can do, everything is going to be a console.log, and we'll do test string dot index of, and we can put in a single letter. We'll put in the letter Z, and if we run that, we get position 38, which is right about over here, I would guess, by the Z. If we ask for something that does not exist, such as two Z's. There are no two Z's in a row, so this should give us, well, either an error or some unexpected number. Well, in this case, the number is expected. It's -1. -1 indicates that it does not exist in the string. Now, the reason why it doesn't give us a 0 is if I had done this and asked for a letter T, it gives us a 0 because T starts at position 0. So remember, we start counting at 0, not 1. So if, when it was not found, we gave 0, that would be ambiguous, indicating that it could exist at the start of the string when it really doesn't exist at all. So -1. -1 means not found. 0 means start of string. So that is the index of. We also have last index of, something that doesn't get used very often, but could have a use. Console.log test string. I should just copy that whole piece and copy and paste it as we need it, because we're going to be using it a lot. So I'm going to do that. And we can do last index of, and we can put in our string, we'll put in G. We only have one G in the string anyway, I believe. No, we do have two. There's one here and one here. So I would expect when I run this, 52. if I do index of, I would expect to get the first G. And I do, 48. So here's your 48, here's your 52. First occurrence of G. And then we have the ability to replace. So why don't we do a replace method that replaces one string with another and returns the new string. So console.log, oh yeah, copy and pasted it. Replace, and we want to put in the value and the new string. So test string is the one we want to start with. And we want to put in, oh no, I'm sorry. We want to search for a value and replace it with something else. Sorry, I got that backwards. So we want to replace dog with cat. And the output now becomes the new string. And here it is at the end, we have cat. So you can see we have another way of modifying strings. And there's quite a bit other ones. We have substring, which gives you a piece of the string. And we can demonstrate that. Sub str. And what's really annoying is that almost every language has these functions for string manipulation, where you have substrings and character ats and index ofs and all that jazz. But in almost every language, they're a little bit different in the syntax, so you kind of have to look them up, especially if you work with multiple languages on a daily basis. It can get a little confusing. So substring, it can have multiple forms. We can have it with just a single number, and it will print out everything from that position to the end. See, we chopped out the very beginning. Or we can give it two values, give it a start and an end. Let's do 20, 30. And now we have a piece in the middle. We have a 20, we start at 20 and go for 30 positions. So you have different ways of doing that. You have a substring, which is a little bit different. Test string dot substring allows us to give us the starting and ending. So we can do, we'll do 20, 30 again just to see the difference. And these are 10 characters starting at 20, ending at 30. The difference here above is this one starts at 20 and goes to 30 characters. This one starts at 20 and ends at 30. Another fun one is split. Test string dot split, and we tell it what character we want to split on. In this case, let's split on the space character. So the idea here is if we do this split, we're going to get an output that has every word separated in, as you can tell, it's an array. So now you're able to take a sentence or some text, split it up into its individual pieces, and then operate on the pieces in an array in a loop. So think about processing a spreadsheet or a CSV file where you could split it with one commas. And then you also have some other interesting ones, but I think we've seen enough demonstration for now. You have stuff like to lowercase, where you can convert your whole string to lowercase. You have to uppercase, where you can convert the whole string to uppercase. And there's a whole slew of other ones. So if you do some string processing, definitely have a look to see what your options are. Languages evolve over time, so you may have some new functions added that weren't there before. But just a quick look at the documentation at that time will give you a good feeling of what you can use and do with string processing. Okay, I'm going to save this code and I will post that into the sample code section so we have those examples. And the next thing I want to look at is the date object. So the date object is, as it says, it's an object that contains date values, and it's a very specific instance in time, and you're giving it that instance of time when you create the object. So I am going to create a date object, and I am going to say let day equals new date, and I will put in today's date. And 15. And there we have our date object. So this gives us the date of October 15th, 2025. And I have a whole bunch of methods that I can use to operate on it. I have console, I'm going to use console.log again. And I'm going to copy this so I don't have to keep typing it. And I'm going to type in day.getDay. And this gets me the day of the date that I picked. Oh, I got a syntax error. New date is not defined. Oh, I didn't put a space there. Sorry about that. So get day. Day returns the day of the week, 0 through 6. 6 being a Sunday. So we have that. Okay, so that just struck me as weird, so I had to do a quick little research here. So the month, which is the middle parameter, is 0 index, meaning it starts at 0, so January is 0. So this 10 is really not October, this is November. So I want 9 for October. So that's a little weird. Now if I run it, I get 3. So 3 means that it's the third day of the week. Again, get day is 0 indexed. So Sunday is 0. So October 15th, if we look at a calendar, October 15th falls on a Wednesday, which would be the 4th day of the week if the first day is Sunday. So that would be the 3. So just keep in mind, you need to understand the values that you're using to set something and the values using to get something. So I was expecting the date object to be 1 base, but it's really 0 base in terms of setting the month. So that was my mistake. So this date here, this is October 15th, 2025, not September. So that's important. So get day of week, 0 equals Sunday. So now let's get back to our examples, and we have some other functions. We can get the year, we can get the hours, you can get any part of this. Well, we didn't talk about time yet, we're just talking about dates. So let's create a new one. New full day equals new date, and we'll stick with our October 15th example. And you could see here from the definition what other values you could put in. You could put a year, a month, a day, an hour, a minute, and a second, and even milliseconds. So you can really get pretty granular. So if I want to put in 4 p.m., I could set my hours. And I'm going to put in hours. 16 for 4 p.m. minutes and seconds. I'm going to skip milliseconds because I don't think we need to get that granular here. And I can do a console.log full date dot, let's do get hours. Let's see what that gives us. 1600 hours, so that's 4 p.m. So you have all these neat functions, get minutes, get month, get seconds, and you could set it. So if I did a full date dot set hours. Let's say I wanted to set it to 17, and then print it and run it and print it. I could set the hours to 17, so I could adjust the time. So how this is represented. So this is represented internally as a count of the number of milliseconds since the operating system Unix was first conceived or built January 1st, 1970. So you could see it's been going around for a little while. It's been going around for quite some time. So, date object. You have a date, you can either set or get different pieces of the date field to do whatever calculations you may want to use. So that's kind of neat. Next up is the math object, and just as it sounds, it gives us access to all sorts of mathematical functions. Exponentation and trigonometry functions and max and minimums and powers and rounding and all sorts of methods that relate to math. So we can just create, well, we can create anything we want. We can create some basic variables. We'll call it var1 equals, and we'll give it 10. And we'll do a let var1 equals 10. And now we can do an absolute value. We can do a cosine. We can do a ceiling. So let's do some of the more interesting functions like cosine. Console.log. Let's see. Math dot cosine. We'll do sine of var1. This is the sine value. It's a trigonomic function of the value 10. And that's going to give us some number. I'm assuming that's right because I don't really do trigonometry that well, but that's fine. So we can assume that's right. We can do all sorts of other math functions. We could do math dot absolute value of minus 12. And that should give us the absolute value, which itself is 12. We can do a round. We could do a floor. There's a whole list in the textbook you could take a look at, but it gives us a way to manipulate mathematical values. We have dates, we have strings, we have math, and we have looked at objects and maps. So we looked at quite a bit, and in the next video, I'm going to wrap this one up now because it's getting a little late in length. The next one we're going to take a look at is how we can use variables. We're going to look at their scope with the let and the var definitions, and we're going to see how we can write some code to demonstrate the scope of those variables, both in the Node.js or the console testing we're doing here, and then we're going to pull it into a web browser, because are some differences between Node.js and web browser implementations in terms of the global scope. Well, we're going to get into that in another video. So I will copy this also and put it into the sample code so you can tinker with it. But just know of it, it's there. You may have some use for it. I would think that most of these advanced JavaScript data types and operations and objects would be more for a standalone operation using a Node.js implementation rather than in a web browser. But it is very important to still know it's there, especially if your end goal is to one day become a full stack developer and you want to use JavaScript. So that's it for now. Another video coming with the let and var comparisons, and then we're going to start bringing it back into web pages and web browsers and see how all this JavaScript ties in with the HTML and CSS. Okay, that's it for now. See you in the next one.